Right, hello guys, this is Monday the 16th. This is a huge class.
Hello.
Yes, so this is weird, Kaya. I don't think I have ever in my whole career have ever had an official class of one. So after all these years teaching, I have a class of one. Hello, Kaya.
Hello.
Hello guys. So I'm going to continue from where we stopped last time. Last time we reviewed natural numbers, integers, rational numbers, irrationals, and real numbers. That was 1.1. 1.2 is about approximation, decimal places, significant figures, percentage error, and estimation. I think I'm not going to do anything in particular, Kaya, here because every kind of problem talks about approximation, decimal places, and significant figures. Important thing to remember: decimal places. Usually they're asked for when we do currency. Significant figures, usually it's three significant figures. Percentage error, you use the percentage error formula. For estimation, you round the numbers into one significant figure. Okay. So the estimation implies one significant figure. Now, 1.3. 1.3 is scientific notation on the form, so numbers in the form a times 10 to the power of k, and a is a number from 1 to 10, so this is scientific notation. Again, I'm not going to do something in particular because a lot of problems use that, so we have seen it in many problems. And the same with different units. For currency conversion, this is 1.5. Is problems that we go from change from different currency, and it's clearly stated here that students should be able to perform currency conversions involving commission. So you are expecting definitely problems with commission. All right. Question, and it's up to you because I know it's one, but it's only you, but you can. Would you like to see a couple of current currency conversion problems to work on?
I think I'm fine with the current.
Okay, so you don't want to see something like that. All right. So we'll continue with use GDC to solve pairs of linear equations in two variables and quadratic equations. I'm going to pause just for a second because you are the only one that uses the TI Inspire, so I can show you personally, and we'll come back. We're gonna take a pause, guys. Okay, and we're back because Kaya is the queen, the queen of the TI Inspire CX. She knows how to use it perfectly. So, thank you very much, Kaya. Next, 1.7, we have arithmetic sequences and series and their applications. So here, and 1.8 geometric sequence and series. We see these problems, both of these problems, so many times. Lately, it's been 2 or 3 years that we keep on seeing this as paper 2 questions that involve both. One part with arithmetic, one part with geometric, and combinations of two. So, should we do a couple of current problems on that? So, I'm going to pause and come back to find a couple of problems to review. And after that, the last part of topic 1 is 1.9, which is financial applications of geometric sequence and series, which is the compound interest and the annual depreciation. So we might not get there today, but basically it took 1 hour to cover topic 1, which is the way you should keep on rotating between topics. All right, so this is a question, a very recent question on the topic from 2019, and it's beautiful because it covers kind of everything. It even has currency conversion and sequence and series, which is great. So, John purchases a new bicycle for $880 and pays for it with a Canadian credit card. There is a transaction fee of 4.2 charged to John by the credit company to convert this purchase into Canadian dollars. exchange rate is $1 is 1.25 Canadian dollars. Then John insures his bicycle with a US company. The insurance company produces the following table for the bicycle's value during each year. So the first year it's 880, the second year is 705, the third year is 763.20, etc. The values of the bicycle form a geometric sequence. During the first year, John pays $120 to insure his bicycle. Each year, the amount he pays to insure his bicycle is reduced by $350. First, calculate in Canadian the total amount John pays for the bicycle. Second, find the value of the bicycle during the fifth year. Give your answer to 2 decimal places. Notice it's in bold. It's going to be in bold in the actual exam. Notice this. C. Calculate in years when the bicycle value will be less than $50 US dollars. D. Find the total amount John has paid to insure his bicycle for the first 5 years. And notice what is the total amount. E. John purchased the bicycle in 2008. Justify why John should not insure his bicycle in 2019. So I'm going to stop the video right now so we can think about it and we'll come back. Alright, and we are back ready to give solutions. So the first question is we're going to calculate, the total cost. Let's see. So calculating CAD, the total amount John pays for the bicycle. So I think the idea here is that we're going to do the 800 USD. Gonna change them into Canadian dollars. So to go from 1 to the number we multiply, we have said. So I don't know if that rule is helping, but for me, after this rule, I can do anything. So 8 times 1.25 is the Canadian dollars, which when you do it, I found 1,100.
Yeah.
And then there is a commission of 4.02. How did you deal with that? 4.4. There is a 4.2% commission.
I divided it by 0.042.
Okay. There is multiple ways of doing it. The first way to do it is that first of all to write this number as a decimal. It's 0.042. Okay. So that is the commission. So if you multiply 1,100 by 0.042, which is, you find the 4.2% of, so that is a multiplication, not a division. The best way, I think, is, so there's 2 ways. The first way we have been to do 1,100 times 0.042.
Oh yeah, and then you subtract.
No, you don't subtract. So that would be 1,100 times 0.042. You find 46.2 or 0.20, and then you add this. So this plus it's 46.20. So plus 46.20, and you find the final answer, which is 1,146.20. A second way, which is faster, is to multiply 1,100 by 1.042. And when you do this, you kind of include it's like an increase by 4.2%. So when you do this, you get immediately 1.042. You actually get on the calculator 1146.2, and you add the extra 2. so you can have the Canadian dollars. Are we alright with this?
Yeah.
Okay. Second part, it says find the value of the bicycle during the 5th year and give your answer to 2 decimal points. So for this answer now, there is multiple ways of doing it again. So multiple ways of doing it is that you start with 800. So you start with 800, and then I think they gave you the other numbers that were
880.
704, and then you get 563.20. 563.20. So this is U1, this is U2, this is U3. We know that it's a geometric sequence, so R is U2 over U1, which is 4 over 5, or 0.8. Alright?
The first one was 880.
Oh yes, sorry. That's what you said, yes, 880. So, what you do, you use the calculator here, if I can find the calculator. Okay, and you work like that, 880, enter, alright, and you times by 0.8. So you find the next value, 704, 763, 450, so 1, 2, 3, 4, 5. So if you put these numbers down, U4, you will be okay without even writing any formulas. Oh, so what was U4? So 450, 56. 454, 56. And then U5 is
360. Oh, 448.
360, you said.
44.
So 360, 448. So the correct answer is in 2 decimals, 360.45. That's the value. Of course, you can also do it using the formula that U5 equals U1 times R to the n minus 1. So you find 880 times 0.8 to the power of 5 minus to the power, it's the same thing, 360.45. Are we right with this?
Yeah.
Okay. The next question now. So the next question now is calculate, I don't know if I see very well, calculate in years when will the bicycle be less than 50. So you can kind of continue the same kind of thing here. So you can kind of continue the same thing. So that was number 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if you kind of run this and you list these numbers, provide the list, you find that the answer is 14 years. So that would be an easy way. So provide the list. So provide the list. Provided the list, you get 14 years. If you don't want to provide the list, you just do it, or you just solve it. 50 equals U1, which is 880, times 0.8 to the power of n minus 1. And how can we solve this? Using the math solver. So math solver 50 is 880 and 0.8 to the power of x minus 1 or k. So, and it's 13.9. So n equals 13.9. So that means exactly at 13, you cannot have 13.9, it hasn't gone to the 50, so that becomes around, you go to the number 14 years. Okay, are we all right with this? Okay, and then the next question is, the next question was D. Okay. So D, find the total amount that John has to pay to insure his bikes for the first 5 years. It's an arithmetic sequence here. It's an arithmetic sequence that you start at 120, that's your U1, and your D is negative 3.50. Alright? Yes, because it says you keep on paying less every year, reduced by 3.50 every year. So that means that it's an arithmetic that go down by 3, 5. So I am looking for the total. So the total is going to be, using the formula, 5 over 2, 2 times U1, which is 120, plus n minus 1, which is 5 minus 1, times D, which is minus 3.50. And if you do that calculation, you get $565. So he has paid $565 the first 5 years. Okay? And now, the last part to complete the question, which is, I think, in terms of phrasing, the hardest. You told me also you were not able to justify it, so I think this is a typical and hard question. So let's look at it. John purchased a bicycle in 2008. Justify why John should not insure his bicycle in 2019. So he bought it in 2008, so 2008 is a whole year, 2009 second, 10, so I'm just going to count, so 2008 is a whole year, so 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 2019, we're talking about 12 years, they're looking for this. So by counting, we have 12 years of ownership. How you read ownership? So now, let's see the value of the, so what is the value? What is the value in 12 years? The value is, I think if we go into the calculator, the value in 14 years, so if I scroll up, or I can just redo it, the value is 880, that was the beginning of the value, right? Times 0.8, so that's second year, third, fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12. So the value is 75.59. 75.59. So that's the value, all right? And what is the insurance value? The insurance in 12 years. How much so you can provide list. So you start with 120, all right? And you subtract 3.5. Are you all right with this? So that's the second year, third year, fourth year, fifth year, sixth, seventh, eighth, 9, 10, 11, 12, 81.50. So it's 81.50. So provide lists. So if you provide list, the insurance is more than the value, so it doesn't worth it.
So how do you?
The insurance, so you can provide lists. If you want to see it with equations, or with equations is, The first one was 880 times the value is 0.8 to the power of n minus 1 equals to 120 plus n minus 1 times negative 3.5. When this, so you see that when, if you solve this equation, at the moment that they become equal, it doesn't worth it to pay anymore. So let's just do it quickly. So math, numeric solver, so I can just save the video, is 880, and you do 120 plus, sorry, 880 times 0.8 to the power of n minus 1, and then you have 180 plus n minus 1 times negative 3.5, and you just solve, and you find 11.58. So n equals 11.58. So after 12 years, which we have here, it will not worth it. So I will see you later on. Bye guys, study hard.